Hey there, we're back. Wait, I'm curious what this code doing. Well, I'm just joking. It is a word game code we created last time, but it's easy to forget the function of a long program. Speaking of function, remember that at first, this part of code could be used a single function to represent. By giving the function a name, we can easily understand the logic without having to see how it works inside. So we can finally give a function in programming a proper definition. It's a callable unit of logic that can be called multiple times. Just like a machine, inside it, there could be many smaller parts of an assembly line. By wrapping them together, we can use a machine without knowing how it actually works. Now, let's create our first function. We simply use the function keywords followed by the function name, and use big braces to indicate the code inside the function. Next, let's also make the isValid function back. This time, it has a parameter and a boolean return value. For the input, we simply put them after the function name. There, the input value passed in can be treated as a variable that can be used in our function. And for the return value, as it's named, we use the return function to return the value back. Programmers often use result as the name of variable returned in the end for clarity. This part of code for getting a valid input could also be wrapped into a function. And within this function, we actually use the function we've already made. If you understand a function is a compressed package of several codes, it's easy to understand the nested logic. You might wonder if more than one function in your code has a variable named result, will be a conflict. Actually, every new variable you created inside a function is like a little secret that only that function knows about. It's called a local variable, and it's gone after the function ends. So you can use the same variable name in different functions without any issues. On the other hand, variables that are created outside a function are called global variables, and they are like the common sense that can be used in any function or even the main part of your code. Since they are so important, it's best to give them a unique name so they don't get confused. If you're still a bit nervous about forgetting what a function does just by looking at its name, don't fret, we can add some helpful comments to our code. Different programming languages have different syntax, but the most common way is to use a double slash, just like this. Remember that comments don't change the actual logic, they're just there for us as a note and help to work with others. If we think of a function as a book with a title, then we can treat a module as a library that houses all these functions. For a small project like ours, we usually don't create our own modules due to limited functions. But hey, we can always borrow books from other big libraries. For instance, if we want to use more advanced math function, we can import math module. Now we can use the function inside it by module name dot function name. Like this ABS function gets the absolute or positive value of a specific number. Besides functions, module can also store constants, just like the math module contains mathematical constants like Euler's number and pi. As a module contains function and constants, a class is like a blueprint that holds function and variables. Imagine your ID card, it's got all your important details. Since every ID card has the same structure, we can create a class called ID as a blueprint. Unlike arrays, a class can hold data from different data types. Similar to a module, we can also put function inside the class, like changing the validate. But wait, we can't use the data and function yet because it's just a blueprint. We need to create an object, the actual instance of the class. That's where the constructor comes in. This function is like the magic wand that creates a new ID card. Now you can call the function or use the variable using the same syntax as a module. Pretty neat, huh? We spend a lot of time discussing the class. You may be wondering if they're actually that useful for our programming. Well, the key to understand classes is to grasp what they truly are. Remember that when we said that the data structure are made of data, relationship between them and operation towards them? Well, guess what? Those very things are actually components of a class. Arrays, for example, the length of function is actually written like this because it's one of the functions that belongs to an array class. Also, we found out that the strings are also arrays, so data types are actually classes too. For instance, to find out how many characters are in a string, we can also use the length function. Classes are the foundation of data structures and data types. Their importance is undeniable, isn't it? Now, I've got some exciting news. Congratulations! You're now more than ready to make your coding dream come true. For now, we've already learned almost all the essential tools in programming, like functions, data types, variables, constants, condition loops, data structure, and modules. And you are ready to create some extra projects. To help you continue your programming journey, the next video, which is also the last video of this series, will give you some tips and directions. See you there!